Good day, students. You're welcome once again to Bosol Schools TV. In this video, we're looking at the subject chemistry and the topic states of matter. Now we'll talk about state of matter. We're talking about the condition in which matters are. And the next question is, what is a matter? Matter is anything that has mass and occupied space. We have our plants, animals, food, stars, we have the air, we have water, and parts everything in the universe are classified and known as matter. You know, everything in the universe, everything you can see, everything you can feel, everything you can touch, everything you can carry, everything you can do with, everything you relate with in the universe are classified as matter. Now, what differs in the various things you see around you are the various states in which the matters are. And that is why we divide matter into three basic states. That is the solid state, the liquid state, and the gaseous state. That is, they are dividing as solid, liquids, and gases. Now we're looking at the differences and the various types of the three states of matter. Now we're talking about solid. In solid, it has definite shapes and volumes. As you look around your room now, you're seeing various objects. You're looking at those various objects. They have definite shapes. Your cupboard has a definite shape. It either takes the shape of a circle, the shape of a pyramid, the shape of a square or rectangle, or any other shape you can mention. Once it has a definite shape and a definite volume, it is regarded to be a solid matter. Now, solid matters, they have definite shapes and volume because their atoms and their molecules are closely packed together. That is, there is no way, there is no point, there is no way, there is no occasion whereby these molecules and the atoms in a solid are able to change because they are closely packed together. And examples of this are the coin, 5 naira coin, 2 naira coin. Mention them. We have brick. The words used, the bricks made use of in construction. Bricks. We have iron bars. We have banana. We have rock, sand. We have aluminium foil. That is the particles of aluminium. We have ice and we have wood. Those are examples of solid matters. And also when you look at the laboratory, we have beakers, we have test tubes, we have conical flasks, we have pipettes, we have a whole lot of them there in the laboratory that are solid matters. Now when we come down now to liquids. Liquid has definite volume, but the shape of liquids changes greatly with change in temperature and pressure. When you see liquid, I believe every one of us know what is called liquid. We have our water back at home, we have oil back at home, we have honey, we have blood, we have our wine, we have our oil, we have milk, we have alcohol, we have coffee. These are liquids. And you notice that the various liquids, they have a definite volume. Take for instance, you can measure them. What is what I mean by definite volume? Take for instance, a cup of tea. It has a definite volume. Oh, 20 liters of oil. It has a definite volume. Oh, I want to buy 5 liters of petroleum. It has a definite volume. Those are regarded as liquid matters. Now we'll talk about gases. Gases does not have a definite volume nor shape. The reason is because gases, the molecules in gases and the atoms in gases are very loosely packed together. That is, there's a whole lot of space between the various molecules and atoms of gases. And that is why the amount of energy in gases are increased. They have high amount of energy. They take the shape of their container, and that is why you can expand it. Whenever the shape of container is expanded, the gases also move along with it because they are loosely packed together. Example of this is air. Have you imagined? You blow a balloon, and then there's a little hole. What happens to the air? It leaks out because what? The molecules are loosely packed together. We have carbon dioxide, we have water vapor. That is whenever you are boiling water with your electric kettle or with your kettle placed on the gas or stove, you begin to see something coming up from it like steam. It's called water vapor. You also have the ozone layer, we have nitrogen, we have argon, and we have natural gases. Before we end this video, we'll be looking at the differences between the solid state of matter, the liquid state of matter, and the gaseous state of matter, and how these various states can interchange, how matters can change from one state to the other. That is, how matters can change from solid to liquid, liquid to gases, or gases to liquid, gases to solid, or even gases to liquid directly, or even solid to gases directly. We'll be considering this in this lecture video. Now we have the differences between the three states of matter. As I've explained earlier on, we have here solid, liquid, and gases. And as earlier mentioned, solid has definite shape. That is, a solid. Take for instance your notebook. Oh, it's rectangular. Take for instance your phone. Oh, it is rectangular. Take for instance a cube of sugar. Oh, it takes the shape of a cube. Take for instance, you can also mention my football. Oh, it's a circle because it's circular. It has a definite shape. But when we're talking about solid, they don't have a definite shape because changes in temperature changes the states of the shapes of liquids. And also when we come to gases, no definite shape also. They also don't have definite shape. Now we'll talk about solid. They have definite volume. That is, you can calculate the volume of a solid. You can calculate, you can get it basically. Oh, this is a circle, the volume of a circle. You get it mathematically from mathematical experience of areas and volumes. And then you also have, oh, it's a pyramid. You get the volume. Oh, it's a cube. You get the volume. They have definite volumes. We have liquids. No definite volume. That is, a liquid, the volume of a liquid is the volume of the container. That is, it only takes the volume of the container. And also, it also takes the shape of that container. If the container is circular and you pour water into that circular container, it becomes like what a circular object. That is what liquids for you. Also, gases, no definite volume. Gases don't have definite volume. When we come to solid, they have a fixed mass. In fact, everything have fixed mass, because for solid the mass is fixed. For liquid, they take the mass of the container, because when you measure them, you pour 20 liters of liquid, that is the mass it takes. You have gases also, it takes that mass. For solid, particles vibrate and rotate about a fixed position, because these particles are all clustered together. Can you imagine? You woke up this morning, you left your room, you went to the sitting room, and before returning back to the sitting room, your bed has moved. Can you imagine? No, it never happens. Because what? The particles, the molecules are closely packed together and fixed to a position. When it comes to liquid, in liquid the particles vibrate, the particles rotate and move about within a restricted place. That is, if the liquid is inside a glass, the liquids, though they move together, the particles are moving together because they are not as closely packed as the particles and molecules of a solid. They move together, but they are restricted to the container. When it comes to gases, particles move about constantly at great speed and at random. That is, there is great collision between the particles of a solid. The particles continue to move. The particles are always moving with great speed because they are loosely packed. They are not closely packed at all. There's enough space between them. So the particles are just loosely packed together, and this way they continue to move with great speed. For solid, solid cannot be compressed. Solids, I repeat, cannot be compressed. You take, for instance, you have your pack of matches back at home, and then if the packs of matches are filled, can you tell me, if you should add an additional matches, what happened? The packs caught up. Also, take for instance your toothpick back at home. If it is filled and you try to add just a stick of toothpick, what happens? You either break the container or the toothpick refuses to even enter at all. Because what? The solid state of matters cannot be compressed. When you try to compress them, you break them. Liquids cannot be compressed. If your glass of water is filled, students, I believe you understand, any additional water you pour into that glass of water is a waste, because liquid cannot be compressed. When it comes to gases, they can be compressed easily. Why? Because the particles are loosely packed, because there is a great level of spaces between the molecules of the particles of a gas. When it comes to solids are very dense. Liquids are less dense, while gases are least dense. Now look at how these various states of matter are able to convert from one state to the other. You see here we have gases. You see here we have liquid, and we see here solid. Now let's start from solid to liquid. Look at this arrow. This arrow is telling us that for this solid To turn to a liquid, it has to go through melting. Take for instance your paraffin oil, or let's even take for instance a candlestick. You know, at the point of purchase, the candlestick is a solid. It has a definite shape. It has a definite volume. But once you light it and it undergoes the process of melting through the introduction of heat, it turns to liquid and begins to melt down. So solids can be converted to liquid through melting. Let's consider this arrow pointing back. And this liquid here can only become a solid through the state of freezing. Have you ever wondered why do you put your water in the refrigerator and after a while it's blocked, it's solid? It's because that's undergone freezing. The particles have been frozen together. But if that same ice is left for a while under the effect of heat, under the effect of change in temperature, it turns back to what? Turns back to liquid. And let's consider now from solid to gases. Now let me make this clear that basically virtually all solids have to be converted to liquid before they are eventually converted to gases. Just a few solid can convert directly from solid to gases, and that is through what we call sublimation. That is what solids that sublime. Solids that have the effect, the ability to sublime are the only solids that can convert directly from the solid state to the gaseous state. I'll talk about gases back to solid. It has to undergo decomposition. That is when these gases are decomposed, they turn back to become solids. Now we'll come to liquid to gases. From liquid to gases, it has to undergo the process called evaporation. Have you ever wondered why is it that whenever it rains and the road looks watery, after the rain is over and you give it some time, probably a day or 2 days, you get to that same spot, there's no trace of water there. It is because the liquids that are there have evaporated to become gases, and they've evaporated into the air. Now from gases to liquid. Gases can only be converted to liquid through the state of condensation. Now students, before I round up today's video, I would like to take a quick recap of what we've learned today. We started by making ourselves to understand that anything in the universe can be categorized as matter, but it depends and varies with the state. Either they are solid, the liquids, or they are gases. And for solids, we say solids have definite shapes and volumes. For liquid, we say that liquid has definite volumes but no definite shape. For gases, we say gases has neither definite volume nor definite shape. And then we look at the differences between the solid, the liquid, and the gaseous states of matter. Then we looked at how the various states of matter can be converted from one state to the other. I hope you do enjoy this video. Please If you are new to our channel, don't forget to subscribe to our channel and don't forget to like our video.